Hello, I'm Charles Clark, and I'd like to start this demo with a very quick science quiz. Do you think I'm going to be able to fit the contents of this into this? Probably not, right? So this is the plans for my virtualization environment with all that wonderful thin provisioning and dynamic resource allocation, and this is the reality of the resources that I have to provision them into. So capacity planning is really a key part of any virtualization strategy. It helps determine IT budgets, it helps impact performance, and great planning about exactly where resources should be placed to get the best out of them. So with the Veeam management pack for VMware, we've been able to incorporate capacity planning into System Center reporting, and we can use that to make good decisions about the virtualization environment going forward. So let me give you some examples. Here we're looking at the reporting node inside the System Center Operations Manager console, and you can see that with the Veeam Management Pack we've now added Veeam VMware Capacity Planning reports. Under that node we have 4 different reports. We have host failure modeling, performance forecasting for data stores, performance forecasting for clusters, and virtual machine capacity prediction. So let me start with virtual machine capacity prediction. So how many virtual machines can I throw into my environment, and where can they go? Where are they going to be able to fit? So if I just open up, I've actually already opened the node there, so if I just open up the dialog here, I just want to explain a couple of things, and this will be common across the demo. So we can see here that we want to look at historical data, so usage historically, and then project that going forward. So here I'm just going minus 30 days to plus 30 days. I want to do capacity planning for clusters and for data stores in this particular example, and I can set thresholds in terms of what should be the acceptable utilization. So what's going to be the acceptable utilization for CPU and for memory, and in this case I've got them both set to 90%, same thing for IOPS and a number of vCPUs per core. So with virtual machine prediction, what I really need to figure out is what sort of virtual machine, what's going to be that average workload that I want to be able to provision into my environment. So I can simply click add object or use add group here to add, what's a typical virtual machine that comprises a service or comprises this particular use case. So I'm just going to look for a VM. Let's go for this one here, AUVBR01. There it is. So I've added that in as kind of a template, if you like, to build the analysis off of. And I'm just going to run the report. Remember, everything with Veeam is using the native SCOM components, so this is just data being pulled from the data warehouse. Of course, I'm using SCOM reporting to do that, but if you have another method of doing that, then it'll all work. So let me give you a quick guided tour to this report. So if I just sort of scroll down here, you can see that we're providing the report parameters, we're providing a summary of the environment that's actually being analyzed, actually being described. Here's the sample workload being described. So this is the workload in that virtual machine that you saw me pick in the earlier dialog. So you can see it's got 4 vCPUs. It's consuming about 6 gig of RAM, and it's actually pretty big. It's about half a terabyte in size. And underneath that, we can actually see where at a glance are going to be the best places to put those resources. So for example, from a cluster perspective, from a compute perspective, you can see that I'll be able to squeeze exactly 0 of those types of VMs into the EU SE Lab cluster. But in the support lab cluster, actually I should be able to squeeze 7 VMs onto that particular cluster. Where, from a storage perspective on that cluster? Well, we can actually see that summarized underneath. So I'm going to be able to fit 4 onto this data store for argument's sake, 2 onto this data store, and I'm pretty tight for space elsewhere. So if I just drill in again, we expand those out. So there's the SE Lab cluster. Let me just drill down to the support lab cluster because that's where we do have available resource. And you can see that based on CPU, I can actually add about 41 of those types of VMs, but based on used memory, I can only add 7, and we can see the sort of percentage of total in terms of what the predicted usage would be based on the parameters that are provided earlier on. And then from a storage perspective, I can see what that capacity is and how many virtual machines I'm going to be able to add based on free space and based on the existing IOPS. So incredibly useful information to help me figure out exactly where in the environment I can squeeze data from or squeeze capacity from and get the best bang for my buck in terms of provisioning a new service. Now, of course, capacity planning isn't just about predicting where I should put virtual machines or how many virtual machines I can squeeze into my virtual infrastructure, but it's about looking at long-term performance forecasting and figuring out when I need to provision new resources. So, when do I need to persuade the CIO to, get his checkbook out to buy me some more storage or buy me some more RAM. So I can look at performance forecasting for both clusters and for data stores. And let's delve in and take a wee look at that. We'll start with clusters. So here I would simply add the cluster or all the clusters that I wanted to analyze. So in this case, I'm going to add a particular cluster, which is the AUSE cluster, which is right there. So I just add that VMware cluster as an object to be analyzed, and I run the report, and here we go. Okay, so again, we can see a summary of the cluster here in terms of the VMs that are actually in use, memory in use, and then as I scroll down a little bit, you can see that actually that performance forecasting that I'd applied as a parameter has failed, and actually we have somewhere in terms of memory utilization in the region of 0, so we're either at full capacity now or at 90% capacity now, to 39 days, best case, of capacity on that, of 90% capacity in that particular cluster. You can also see that we're making a recommendation about the best way to, make sure that we do get long-term use, and very simply, the recommendation here is just to add another 6.62 gigs of RAM. I can actually drill in and see that in more detail. So you can see that we may be hitting that 90% threshold within the reporting interval, and you can see the stats that have comprised that here. So the worst case scenario is that we'd actually be 100, more than 100% of utilization from a RAM perspective. Best case is we'd only be at 87%. Now, it could be that there are peaks and troughs that are actually influencing those figures. So we can come in and have a look and see how smooth over the reporting interval that chart is, and see whether or not there was a spike, an outlier essentially, that was influencing those figures. Looking at this chart, it looks fairly flat to me, so I reckon that those figures are reasonably accurate. You can do the same thing for data stores, or a similar thing for data stores. Here I would simply add the data stores I was interested in. Again, I apply the thresholds that would represent a breach in that capacity forecasting. I'll just go ahead and run that. I'm just doing this against all my data stores rather than against a single data store or a group of data stores, but those would be options for me too. And we get the results. So again, we can see a summary of the results. So this will highlight just the problematic areas for me. So we can see the data stores that will fail and pass based on the criteria applied inside the selections earlier on, and you can see what that recommendation should be. So you can see that, for example, this data store here, SUP ESX02 DS1, has passed for write latency, and actually we're probably not going to need to add any more resources to alleviate that latency for about another 10 years according to the report here. But then if I look at this data store here, Veeam Backup AU Backup 02, that's failed for provision space, and actually on that data store what this is telling me is I'm going to run out of provision space on that data store somewhere in the region of 5 to 14 days. So I better go and make an emergency request. This is based on the growth pattern for the data store. Make an emergency request to make sure that I don't run out of space on that data store and it doesn't cause an outage for me. Of course, what I could do is simply move VMs around, and we provide a handy recommendation here to reduce over provisioning by 365 gig, which should take the pressure off of that data store. And if I drill in and look at any one of the data stores, again, I can do the same sort of analysis I could with clusters, so I can have a look at trends and deviations and figure out, using the raw stats essentially, whether there may be any outliers that are impacting those results. Okay, now the other thing that I need to figure out is I may have hosts living within a cluster, and from a capacity standpoint, I need to plan for capacity shift. So if one of those hosts fails, what's going to happen? Stuff's going to move around. Are things going to break? If I move stuff from one host to another host, what's going to happen? And at what point will performance degrade on the hosts that are still left running in the cluster? So host failure modeling in the Veeam management pack for VMware really does that for us. So I'm just going to go ahead and run that report. You can see I've set the CPU threshold here to be 65, and I'm just going to run the analysis against all the VMware clusters here. We'll see what this spits out. Okay, so again, we get a nice summary of what the usage is on the cluster and the problematic areas for me. So again, I can see that in the SE lab, the result is failed because, I've got, basically all resources would be gone in the event that there was a failure. The reason for that, as you've probably guessed, is there's only one host in that cluster. So if that host fails, goodbye cluster. The support lab, though, has passed. So let's take a look at the support lab cluster. So what we're getting here is a graphical representation of what happens if one of the hosts in that cluster fails. We see this represented by these, nice wee donuts here, or bagels if you're feeling healthy. So if I remove one of those hosts, of course, then I've only got half of the resource left. So from a CPU perspective, we're taking away 24 gigahertz, taking away 48 gig from a RAM perspective. And I can drill in and see, if I did have that host failure based on those thresholds I defined earlier on, how many days left do I have running at that limited capacity? So, worst case scenario from a CPU perspective, I'd have, 743 days, so, a couple of years. From a memory perspective, though, that's a little bit worse. I would have, just shy of a year. So I don't think I'm in any imminent danger here if I do lose a host, but it's good knowledge for me to have in case the resources on that cluster are running a little bit tight. So capacity planning is a key part of any virtualization strategy, and it makes sense to use tools and reporting that really give you an insight into the best way to make decisions about capacity for your virtualized environments. Thank you.